Hey, I am Mridula Murali. I'm a graduate student at University of South Florida. Today I will explain you how to build a decision tree and neural network model using SAS Enterprise Miner. And also we will look at some concepts that we should be aware of while building a model. So let's start our SAS Enterprise Miner. So I've already created a SAS Miner project here and a diagram breast cancer type. So I've already given some inputs. The first one is a file import. So we can browse the file using the import file, and so let's see our data set. So here we have the sample code number, clump thickness. So let's see the attribute. So these are my attributes here. So here I am predicting whether the breast type is whether benign or malignant, 0 for benign and 1 for malignant. So these are the other attributes. So we can edit the variable here in the file import. So these are my variables and the class is my output variable, so I have set it as the target variable, and since that is a binary, I have set it as binary. All the numerical variables I have set it as interval, and for categorical we can set it as nominal. And see, the sample code number I have given it as rejected because I'm not considering that variable here for the prediction. Let's click OK. So then we can give the stat explore button here from the explore and stat explore here. So it will help in variable distribution and statistics of the dataset. So we can see the output here by right click and run. So we can see the results here. So it gives the variable worth, so how much that variable is worth for the prediction, then the output here. So from the output we can see that there are no missing values here in the dataset. So next, after the statistics, we can give the data partition. We can take the data partition from the sample and here the data partition. So I would like to refer to our first concept, that is the overfitting issue. So if you train the data too much, it will cause overfitting issue, and we can avoid that problem by partitioning the data into training, validation and test set. So here we can split it as, so I have split it as the 60, 20 and 20. So after data partitioning, we can start our data modeling. So to test for different models, we can use the control point. So in the utility tab, we can take the control point and drag and drop here. So this is our control point. We can give the output here. So let's run the data partition first and check the partitioning of the data. So we can see the results here. So we can see that out of the total 683 data, 407 have been taken for the training, 137 for the validation and 139 for the test. So let's just model using a decision tree first. So this is our decision tree. So we can give the output here. So for the decision tree, we can set here the maximum branch and depth. So we should always consider stopping rules for the split of a node. That is our concept number 2. That is, we should not further split the node if the node size is too small, or we have already got the 100% accuracy, or if further split doesn't improve the accuracy of the model. So here we can maximum branch I am setting it as 5 and depth I am keeping as such itself. So the decision tree, so we can just run this and check the output. So we can see the results here. So this is our cumulative lift. So it gives the prediction, effective measure of prediction of a predictive model. So we can see here for the training and the validation. And this is our tree. So this is our root node, and we can see that it is splitting based on the uniformity of cell size and the bare nuclei. And I would like to refer to our concept number 3, that is, always be beware of spurious correlation. Even though this may seem as a correlation, some variables may not be actually correlated. So it is always to be checked further for spurious correlation. So we can just close this one. And let's give our other model, that is the neural network here, and That is our concept number 4. That is the importance of experimentation. That is always try different models and experiment the results using different model to be sure of the prediction output. So we can give the output here of the control point. So for this we can set the network. So the architecture we can give as a multi-layer positron itself, and the optimization we can set as training technique, we can give it as the back propagation. I'm setting the maximum time from 4 hours to 30 minutes and the maximum iterations to 25. So okay, now we can see the output of the neural network. So let's run it. So we can see the results. So from the results we can see that so this is the hidden layer 1, hidden layer 2, and we can see the different weights. So we can also see the confusion matrix, the true positive, true negative. We can see here in the validation test set that we are having 5 false positive and 4 false negative. So let's close this and compare our model. So we can compare the model using the model comparison from the access tab. So we can give the output here, the output from here. So let's run our model. So let's see the results. So here we can see the ROC curve for the decision and neural network and the cumulative lift. And this is our fit statistics. So from the misclassification, you can check the misclassification rate. So we can see here that the decision tree is better than the neural network here. And thank you.